So we want to begin looking at lines in section 3.4, and we're going to start off with looking at a lesson of what we call the slope of a line. It's our first really big topic we want to introduce, the slope of a line. So imagine I have 2 points. This is my first point. Call it P1. And let's give it the coordinates x1, y1. And my second point, where are we going to put it? Let's call it P2. Put it here. And we'll call it x2, y2. Those are the coordinates. And if you connect those 2 points together, you get a line. And actually, a line continues forever, if you want to be technical. A line segment stops at those 2 points, but a line continues forever. Now down here, let's imagine that this is the x-axis. And here we have the y-axis. If I trace this point to the x-axis and this point to the x-axis, I'm going to have that this is x1, right? That's the x-coordinate of P1. And the second one here is x2. That is the x-coordinate of P2. And if I trace P1 to the y-axis, I'm going to get a y value of y1. Why y1? Well, because y1 is the y-coordinate of P1. If I trace P2 to the y-axis, I'm going to have a y value here of y2. Because y2 is the y-coordinate of P2. So, essentially, slope we think of as rise over run. Rise divided by run. So it's the ratio of the rise divided by the run. So the idea is you're going to rise a certain distance from your first point to your second point, and you're going to run a certain distance from your first point to your second point. So the rise, that's the vertical distance that you would have to go from the first point to the second point. And the run is the horizontal distance that you would have to go from the first point to the second point. So, let's come up with an equation for the slope, rise over run. Let's see. If you imagine the distance here between y2 and y1, you're going to take the larger number, y2, minus the smaller number, y1. So that's your rise, y2 minus y1. That's the rise here, how much you're going up. So here, in place of rise, I'm going to put y2 minus y1. Now the run, that's basically the distance from x1 to x2, right? x1 to x2, that's going to be x2, the larger number, minus x1, the smaller number. So here is the run looking on top. It's x2 minus x1. Now I'm going to replace the run here with x2 minus x1. So this gives me an equation for the slope. So let's write that down nicely. I'm going to scroll just a little bit. Let me get my pen back. And give me a formula for slope. Slope formula. The slope of the line passing through the points x1, y1 and x2, y2 is given by the following formula, or defined to be m is the letter we use for slope, is y2 minus y1 divided by x2 minus x1. So this is the formula we're going to use for slope as long as x2 and x1 are not equal. So x1 is not equal to x2. So here is our formula for slope you'll want to know. Now, why do we have to say that x1 and x2 can't be equal? Well, if x1 and x2 were the same, you'd end up getting a 0 in the denominator. And if you had a 0 in the denominator, well, that would be a big problem, right? You can't divide by 0 in math. So we want to add one more thing here. If x1 and x2 are the same, if they're equal, then the slope is undefined. Then m is undefined. Very important. Let's scroll a bit more. So we want to look at some characteristics of the slope, some facts about the slope. So let's think about an example where we have a slope of 3, m equals 3. So let's say here's my starting point, my P1, and to get to my ending point, P2, I'd have to rise 3 and run 1. Why? Because 3 is the same thing as 3 over 1, right? We have to rise 3, that's the top number, and run 1. So up 3, right 1, plot a second point. It's going to be my P2, and then we connect the 2 points to get our line. So another example. Let's look at when m is equal to, let's say, 1/3. Now think of this as up 1, right 3. So I'm going to start here with my first point, P1. And I'm going to go up 1. So that's my rise, up 1. And then I got to run 3. 1, 2, 3 to the right. That's going to be my P2. And connect the 2 points and you get your line. So notice that both of our slopes were positive slopes, right? The first slope was 3. The second slope was 1/3. And notice how both of those lines are moving in an upward direction from left to right. So as you go from P1 to P2, the line moves in an upward direction. We call these increasing lines. So an important fact here we're going to establish is if the slope is positive, m is positive, then the line is increasing. And I'll just draw a little picture, increasing. That means as you go from left to right, the line is moving in an upwards direction. Okay, we want to do another example here. Let's say we have a slope of -2. Ooh, a negative slope. Weird, right? You can think of this as -2 on top and 1 on bottom. So let's start with a point. Call it P1. And remember, slope is rise over run. So if the top number, if you imagine the top number being -2, that means you're going to have to rise -2, which means you go down 2. And the bottom number is a positive 1, so you're going to run positive 1. So you're going to move right 1. Plot a point. That'll be your P2. And then you connect those dots to get your line. All right, let's do another example. Scroll just a bit. So this time we're going to do m is -1/2. A slope of -1/2. That's -1 on top, 2 on bottom. So let me start off with a P1. A P1. And if the top number is -1, that tells me to rise -1, which actually means to go down 1. And then my bottom number is +2, so I'm going to run 2 to the right, run +2. So I'm going to plot a second point, P2, and I'm going to connect those dots. So notice that in these little second examples where you have negative slopes, notice what's going on with the line. It's going in a downwards motion as you go from left to right. Right? From left to right, the line's going down. It's called a decreasing line as you go from left to right. So let's write that important fact down. Here, so we have if m is positive, the line is increasing. If m is negative, then the line is decreasing. So again, decreasing means as you move from left to right, the line's going in a downwards direction. Okay, now let's notice a few other things. Notice when we had a slope of 3, right, and a slope of -2, again, slope of 3, and a slope of -2, something is going on with the line. Notice how steep the line is, right? When it's 3 and it's when -2, the line is really steep. So what we're going to say here, we're going to write another fact that if the absolute value of the slope is bigger than 1, then the line is steep. Yeah, so let's think about that one more time. You took the absolute value of -2 here, right? Absolute value of -2 would be +2. That's definitely bigger than 1. And we have a steep line. And if you go back to the example where the slope was 3, if you take the absolute value of that slope, you get 3, right? Absolute value of 3 is 3. You got a steep line. So anytime the absolute value of your slope is bigger than 1, then you have a steep line. Now let's look at the example where the slope is -1/2, and the example where the slope is 1/3, and notice how gradual those lines are. So for example, 1/3, I would be going up a hill, if I'm going from left to right. That'd be a nice hill to go up. It's not too steep. And if I'm -1/2, my slope's -1/2, I'm going downhill, it's not too steep, right? It's gradual. And notice if I take the absolute value of -1/2, the absolute value of 1/3, those are smaller than 1, right? They're between 0 and 1. So what we're going to write is another fact. If the absolute value of m is less than 1, then the line is gradual. Important fact.